Hello, hello, hello! Welcome to another video of linear algebra. We are in the blackboard and we're going to be doing some examples on change of bases. I will say that this example can be done really quick, but I'm going to dedicate this entire video on just this example just to explain a little bit more on how it looks visually and do my best to help you understand what you're looking at and what you're or how you're supposed to be interpreting every single step. So in this first example, we are given a coordinate, or I guess a vector x b, that is the transpose of 4 1, and we are given the base b is equal to 2 -1 and then 0 1, and we are told to find x in terms of b prime, where b prime is the standard bases. So because we're working on standard bases, this would be a really good way to think about how when you're switching to one base to another works. And since the standard bases, as I discussed in my linear shorts, if you have not seen it, the link will, or the card will pull up. But it standard bases for, in this case, it's a XY plane. For this example, is something that we've been dealing with since we were like little kids, and so it's something that we are very familiar with. And so this example will kind of help us how to visually see and how to interpret what everything means. So the first part is to figure out this 4 1 transpose. Well, this is pretty much saying that it's equal to 4 1 because it's the transpose. That's pretty much it. And so the bases that we're given, bases b, that is something that we can use. So this basis b, this is basically telling us that this is the bases vectors as viewed in standard bases. So another way of saying this is for xb. So for xb, their 1 0 is actually, from our perspective, to -1 from our general perspective. So basically standard bases. So this or we're just gonna say that this kid's bases, or this kid's set of their 1 0, to them it looks like 1 0, but to us it's actually 2 -1. And then the same thing goes for 0 1. So that also means their 0 1 is actually, well, it's the same one as 0 1. So we can see that the j hat, so basically the y axis portion, or our y axis, the j hat, it did not change at all. Their 0 1 is our 0 1. The I hat, which is what we usually interpreted as the x-axis, that one changed. We are used to seeing 1 0, but for them it is actually to -1 when we look at it. And so now what we have to do is we have our coordinate in terms of one base. We have the bases viewed, the basis vector as we viewed it in the standard basis form. So in other way, this portion is our translator. And so we can use this to find our xb prime, which will be in standard bases. So we remember that this is b prime is equal to p times xb, and this portion is our b. So all we had to do is just substitute that in, and we had to remember to convert this portion up here into a matrix. Those would be 2, -1, 0, 1, and then you multiply it by 4, 1, 4, 1, 4, 1. When you do that, you'll get 2 times 4 is 8, 0 times 1 is 0, and then we have -1 times 4 is -4, plus 1, and we have 8, -3 in terms of b prime. And that is our coordinate system at b prime. And this notation is very important. We have to specify that this is b prime, because this is telling us that in this base system, or in this coordinate system, it would be that same point that was, what is it, 4, 1. For us, it's going to be 8, 3. And so that's pretty much the proper way to do it. There is a much shorter way, but you kind of have to do not more steps, but it's you don't have to do the matrix multiplication if you forget. But the other way, which is much more like, I'll say a quote unquote simple way, would be, we know that xb is equal to 4, 1. So xb prime would be equal to some constant times 2, -1, plus some other constant 0, 1. And we know these constants are the d4 and d1. That's a terrible arrow. We just substitute that in to 4, 2, -1, plus 1, 0, 1. Put them together, we'll get 8 minus 4 plus 0, 1. And then we get 8, again, -3. And then we put it in its matrix form, prime, 8, -3. And that's another way you can do it, which kind of the same number of steps, but you don't have to worry about putting the bases that were given in the matrix and then making sure that you actually did the matrix multiplication correct. So this is a much more simpler way and doing it. And so now I'm gonna like visually show you that this is actually 8, -3. So I'm gonna put this in, have this a coordinate system. It's big enough. Okay, so let me actually try to zoom in a little bit. Okay, so we have a coordinate system. We're gonna start like right here. Yeah, right here. And then obviously this is gonna like expand out. That is not that is not supposed to be x. It's supposed to be y. X. Okay, so this is gonna be standard bases, or this color would be, I'm actually make this thinner. This color would be standard bases, and then this color would be, I'm just say wacky. It's not really wacky, but like it's just kind of odd, because like, you know, we're used to 0, 1 and 1, 0, so it's just kind of odd. But wacky sounds like a fun word, so so our in standard bases we have our j hat and I hat, which is 0, 1 and 1, 0. So we have our 1, 0 I hat, and then our 0, 1 j hat. Now for them, we were given the the bases of how it's viewed in our perspective. So for them, we know that their j hat is still the same. So this is their j hat, and then their I hat was 2, -1, so it'd be 1, 2, and then -1. This would be their I hat. That is, let me redo the I hat. This would be their I hat. So from this standard coordinate system, this is pretty much 2, -1 I hat and 0, 1 j hat. But for them, which would be, for them, this is still 1, 0 I hat, it's supposed to be a comma, and then 0, 1 j hat. And so if we would kind of like redrew the coordinate system in their perspective, it will be something like, that's not a straight line. Something like this. Oof. Oh, that's terrible. Like, something like that. So this would be their y. This is gonna be their x, and so that's how their coordinate system is gonna look. And you can see it's like very disoriented. But that's how their coordinate system looks. And so now we are going to show that their 4, 1 is actually RA3, and we're gonna use their standard or their coordinate system and how we view it. Their bases as how we view it. There we go. So what was the point? For them it was 4, 1, correct? 4, 1. So right here, so x is 4, so that means you have to multiply this by 4. So this would be, right here is already 1, then right here would be 2, 3, 4, and so the point is going to be, let me just drag there we go. And then it's going to be 1 on the top, well actually the same color, 1 on the top, which would be right here. So this is their point. This is their 4, 3. Now if we would let me like just expand the coordinate system a little bit more. If we were to now look at it, or just like retrace it with our coordinate system, we'll be given, this would be 1, 2, 3, 4, 5, 6, 7, 8. Then 1, 2, 3, 4, 5. These are all negatives. So this would be -1. This would be 1. So right here will be 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, -3. And if you follow down to the side, you will see that this is actually 8, 3 when we -3 when we view it. And I realized that this is supposed to be a 1, not a 3. And so that's how you can pretty much see how that works. We're pretty much, in this case, we are stacking our coordinate system and their coordinate system on top of each other, and then the point that they give, we can just pretty much trace it back to how we see it. And so like I mentioned, for their coordinate system, let me see if I can draw. I'll probably do orange. Their coordinate system is still gonna be, that is not orange. Actually, I'm gonna do purple. Their coordinate system is going to be like this. The y is still gonna be the same. Sorry for my terrible line. But their coordinate system is going to be, yeah, like this, and then this would be 1, 2, 3, 4, 5, and 1 here, and then this is going to be 1, 2, -1, -2, -3, -4, -5, -6. And so that's how their coordinate system going to look, and you just have to trace it. And we pretty much put it on top of our standard coordinate system, and then we just trace back to how it will look in our perspective. So that's another way we can see the change of bases and how it helps us. Now, of course, you pretty much kind of have to have this in your head, if like, especially like if you're like in an exam, because you won't have enough time to really think about it. But you can do this in standard if you actually have the proper time. You could do this in standard bases. However, it's once when you start getting with going from a wacky basis to another wacky basis, then it kind of becomes a little bit difficult to picture it, or not picture it, to like draw it out. But if you have like this sort of intuition in the back of your head, or in your head when you're doing examples, then you can see that this the answers you're getting will make sense. So like I said, this was supposed to be a short example, but I wanted to make sure that you can fully understand it. Here's my linear shorts video. You can fully understand it both from a mathematical perspective, but also from a visual perspective. And so now I will go on to the next example. That I will do another one of these, which will be much more easier. But after that, we'll do a different set of examples, but that'll be for the next video. But as of now, I'm already over the limit. So I'll see you guys in the next video.